There are a few F words you're allowed to use in my classroom. Fun, fractions, and factoring. Everybody loves to factor, and that's what we're going to be doing today. We're going to put the factoring myth that it's difficult away. I don't know what I mean by away, but we're going to prove that factoring is not difficult. By the time I'm done with these problems, you will be a factoring genius. Oh yeah, genius. Now, if you've thought factoring was difficult before, I think I can make it seem pretty easy to you, and you're going to be pretty excited about it. And nobody gets excited about factoring, but you will be, because you're going to be a genius at factoring as soon as you're done with this. So we're going to put all that factoring myths away, and we're going to create the factoring boot camp, 75 problems. I'm actually doing all of them. A couple of them are bonus. And I'm going to go through these, and I'm going to try to make it as easy as possible for you. And then to help me do that is my Dunkin' Donuts coffee. Is there anything better when factoring than Dunkin' Donuts coffee? There isn't. Nailed it! Oh, another great commercial for Dunkin' Donuts. Let's get going. Woo! Factoring. All right. First thing about factoring is always look for a GCF. Is there a greatest common factor? Well, clearly with these things, x squared, 4x, and 3, there's no GCF. They have nothing in common. So I can decide, okay, I'm going to just factor it into the product of two binomials. The only way to get x squared is x times x. Now we're going to look at this number. If this number is a positive, they are going to add to get middle term. Middle term. So I need a way to multiply to 3 that adds up to 4. Well, there's only one way to multiply to 3. It is 1 times 3. Now, if this is a plus, the only way to multiply to a positive is a positive times a positive or a negative times a negative. Since they have to add up to positive 4, both signs must be positive. Now you can check this. This is 3x. This is 1x. They're both positive, and they add up to positive 4x. So there's your answer, kids. One down. Lots to go. Here we go. The only way to multiply to y squared is y times y. The only way to multiply to 5 without using fractions. I know there's lots of ways to multiply to 5, but without using fractions, the only way to multiply to 5 is 1 times 5. Now, they have to add up to 6, positive 6, so they both have to be positive. Again, the signs have to be the same. If this is positive, they're going to add to the middle and have same sign. It just has to. All right, now this is a special case. I'm going to come back to it. Let's do a couple more of these. K times k is k squared. Now, I need to multiply to 49. Well, there's two ways to multiply to 49. 1 times 1 or 7 times 7. Or excuse me, 1 times 49, 1 times 1. 1 times 49 or 7 times 7. But they have to add up. Now remember, this is a positive. So this is going to tell you they have to add to 14. Now right now I don't care about the sign of 14. They have to add to 14. So 1 times 49 doesn't add, 1 and 49 don't add up to 14, but 7 and 7 add up to 14. Now again, I told you, if this is positive, the signs have to be both positive, because the only way to multiply to a positive is two positives, or, where'd you go? Or two negatives. But since they have to add up to negative 14 right here, they both have to be negative. All right, one more. I'm going to take a quick break. Two sets of parentheses. P and P. Now, there's three ways to multiply to 81. 1 and 81, 3 and 27, which you didn't know about, and 9 and 9. I need the pair because this is a positive. I need the pair that add to 18. Well, clearly that's the 9, and the 9 add up to 18. And again, they're either both going to be positive or both going to be negative. In this case, they're both going to be positive. Helps factoring. All right, let's talk about this one. Yes, I changed pen colors. Wasn't that fantastic? X and X. Now, they have to multiply to 8. They have to multiply to 8. That's 2 and 4 or 1 and 8. But I need the pair because this is a positive that add to the middle. Notice how that's a positive and they have to add to the middle. 1 and 8. They add to 9. But it's positive 9, so they're both positive. Whenever this is positive, you're going to add to the middle, and the signs are going to be the same. Now we're going to change things up ever so slightly. Two sets of parentheses. By the way, we're always looking for a GCF, and I haven't seen one yet, so there's never going to be a GCF when that's a 1, so don't bother with it. Well, that's not necessarily true. If they all have a y, there'd be a GCF. All right, so the only way to multiply to y squared is y times y. Wait a second now. Do you see how this is a minus? Now they're not going to add to get to the middle. They're going to subtract to get me the middle. Now let's see. There's a lot of ways to multiply to 90. I'll list them, but I don't suspect that you need to list them, especially since you're in probably Algebra 2, unless you're in Algebra 1, but whatever. 1 and 90. Oops, I shouldn't put in 9. 1 and 90. 2 and 45. 3 and 30. 4. Nope, 4. 5. 5 and 18. 6 and 15, 7, 8, 9 and 10. Now that's a lot of work. You wouldn't probably come up with most of those. Well, let's talk about some strategies. If they have to subtract to get this number right here, and that number is a 1, two numbers that have to subtract to get you a 1, don't they have to be right next to each other? The only way I can get 1 when I subtract is to have two numbers right next to each other. 5 and 6, subtract to give me 1. 7 and 8, subtract to give me 1. 27 and 28, subtract to give me 1. So I need two numbers that are right next to each other. That's these two, 9 and 10. Now, because this is a negative, the signs have to be different. Why? Because a positive times a negative is negative. Or negative times a positive is negative. They have to be different. One of them has to be positive. One of them has to be negative. Okay, well, your job is then, that's why this is a little bit trickier. You just got to figure out, how am I going to add to get positive 1? Okay? If I got to get positive 1, doesn't the larger thing have to be positive? Doesn't it have to be positive 10 and negative 9? Because 10 minus 9 with a negative 9, that's positive 1. That's what we want. That's how you do it. Come back to those, come back to those, come back to those. Do a couple more of these, and then we'll go back to those ones I skipped. All right. So again, notice the number in the middle is a 1. It's actually a negative 1, but I don't really care about the sign right now. I care about that it's a 1. All right. I also know my signs are going to be different. So I need two numbers that are right next to each other, because the middle number is a 1, that multiply to give me 42. And if you picked 6 and 7, you would be right. 6 times 7 is 42. And if you subtract them, remember, we're looking for, they subtract to give me the middle number. If you subtract them, they get 1. Well, wait a second. I want -1, not +1. I want -1. So that means that the bigger one has to be negative and the smaller one has to be positive, because -7 plus 6, that's -1. Okay? There's your factoring. Now notice in this one, my middle number is not a 1. It's just not a 1. It's a 12. That's a pretty big number. 12 is a pretty big number. So when I'm working on these, notice how when the number in the middle was a 1, I wanted them right next to each other. But now the middle is a 12, so I want them really far away from each other. So, and remember, I'm looking for the pair that subtracts to give me 12. Subtracts to give me 12. Well, there's 3 ways to multiply to 45. 1 and 45. Everybody knows that one. 5 and 9. Everybody knows that one. But the one you're going to want for this one is 3 and 15. 3 and 15 multiply to 45. And notice when I subtract them, they also give me 12. So one of them's 3. One of them's 15. It doesn't matter where you put them. If you put the 15 first and the 3 second, that's okay too. But because they have to add up to positive 12, the bigger number has to be positive and the smaller number has to be negative. Now, up until now, and up for this entire first 40 or so, they're actually going to be all relatively simple. They're all going to be kind of like that one. When we get to difficult factoring, and I'll explain how you know it's more difficult factoring, there's some other things to consider, but only slightly consider, okay? Okay, here we go. I should have changed pens. Let's change the pens. We'll go light blue. H and H. H and H. Now they have to multiply to -56, so it's negative, so that means the signs are different. And they're going to subtract. So the signs are different. But more importantly, they're going to subtract to get the middle. Oh, wait. Isn't the middle 1 again? The middle's a 1. So I need 2 numbers that are right next to each other that multiply to 56. And this is where you have to have good math, some good math facts. How about 7 and 8? 7 times 8 is 56. And when you subtract them, you get 1. Well, again, I want -1. So the larger one has to be negative and the smaller one has to be positive. Here we go again. J. Don't worry, kids. I'm going to get to the hard factoring very soon. Ding, 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 ding. Like, look at these problems right here. Like when I start to get to these pages, oh my gosh, that looks difficult. Oh my gosh. And wait till we get, wait, what? Huh? Look at those problems. They're difficult. We're going to get to those. We got lots to go. I don't know where, oh, there we go. All right, here we go. So they got to multiply to -62, which means they're going to subtract to give me 2. So I need 2 numbers. Now, they're not right next to each other, but they're only 2 away from each other. So I need 2 numbers that are kind of close to each other, only 2 away from each other that multiply to 63. So hopefully you picked 7 and 9, because 9 minus 7 is 2. Now, since they have to multiply to -2, the larger one has to be negative and the smaller one has to be positive. We'll come back to this one. All right. After this one, we're going to go back. All right, 2 sets of parentheses. Actually, this one's really easy. There's only one way to multiply to 3. Whenever this number's prime, you're like, oh, there's only one way to multiply to 3. It's 1 times 3. Gotta be. Now, they have to subtract to give me 2. That means the signs have to be different. And they gotta add up to +2. That means the larger one has to be positive and the smaller one has to be negative. Now let's go back over to here. I don't think that was the first one. Where is it? There it is. This is called the difference of 2 squares, or the difference of perfect squares. I call it the difference of 2 squares because I can abbreviate it dots. Difference of 2 squares. This is x times x. This is 10 times 10. or 10 squared and x squared. So, and notice there's no middle term. Now, didn't I say if the number at the end, remember it's always the constant, is negative, they have to subtract to get to the middle term. Well, there is no middle term. That means they have to subtract to give you 10. They have to subtract to give you 0. Well, I need two numbers when I subtract them that I get 0. Well, doesn't that mean they have to be the same? 5 minus 5, 8 minus 8, 12 minus 12. They have to be the same. The only way I can subtract two numbers that they add up to nothing or 0 is to have them be the same number. So when I'm doing dots, perfect square here, perfect square here, the beginnings are x, two numbers that multiply to 100 that add up to 0. Oh, that's just 10 and 10. And didn't we just say that this is really just 10 squared? Yeah. Now remember, because I have to subtract, one of them has to be positive, one of them has to be negative. Well, the cool thing about the difference of perfect square questions like this is they'll always be, this will be x and 10. The square root of each of these will be what goes in the parentheses. I'll explain in this next problem. Z minus 36. Okay. Well, the beginnings are easy. Z and Z. This is a perfect square, so difference of two squares. So what times what gives me 36? 6 times 6. 1's plus, 1's minus. That's all you have to do with the difference of two squares. I don't think there's any more here. I think there was one up here, wasn't there? All right, let me take a break and I'll be right back to that one. Every time I stop to save my recordings, I drink Dunkin' Donuts coffee. It helps save my recordings. Huh? Okay, not a great commercial. But I nailed the not great commercial. Whatever, leave me alone. Okay. I probably should have discussed this earlier in a different problem, but we didn't have a choice. We didn't have a problem like this. So, this is not a perfect square, and this is not a perfect square, but there is no middle term. So they got to add to nothing when I'm done with this. Well, if you remember correctly right at the beginning, I said always, 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 always look for a greatest common factor. So before you factor anything, you always have to look for a greatest common factor. And in this case, the only thing it could be is 3. So yes, we do have a 3 that divides evenly into both these. And we end up with x squared minus, and 3 goes into 75, 25 times. Oh, okay. Well, this here then is the difference of two squares. So what I'm going to do, and don't forget this little 3's got to come along for the ride, I'm only going to worry about this thing I just highlighted. What gives me x squared? X and x. What gives me 25? 5 and 5. 1's plus, 1's minus. Look for a GCF. Do they have something in common? Oh, I can take a 6 out of both of these. Take a 6 out. I'm left with y squared minus 9. Well, y squared's a perfect square. 9's a perfect square. So this is the dots, difference of two squares. 6. Y and y. 3 and 3. 1's plus, 1's minus. Now this next one's a little bitsy different, but not much. Look for a GCF. Do 20 and 45 have anything in common? Well, clearly they have a 5 in common. So let me take out a 5, and I'm left with 4f squared minus 9. Now, are these perfect squares? You bet your booty. That's a 4, and that's a 9. This is an f squared. Everything's a perfect square. Everything is a perfect square. So I can simply factor it. Now, it's a little bit different in this case. What gives me 4f squared? What's the square root of 4? Oh, that's 2. So 2f and 2f. Remember what I said? The parentheses are going to look exactly the same. The only thing that's going to be different is 1's plus, 1's minus. And isn't 2f times 2f 4f squared? And what multiplies the 9? 3 and 3. One's plus, one's minus. Let's see what we got. All right. 2 sets of parentheses. Going back to the old ones now. They have to subtract to give me 13. Now, 13's a big number, so I want them really far away from each other. There's only one way to multiply to... There's 2 ways to multiply to 14. 2 and 7. Those don't subtract to give me 13. And 1 and 14. Oh, those subtract to give me 13. So 1 and 14. Now, since they have to subtract to give me positive 13, the larger one has to be positive and the smaller one has to be negative. What's the first rule of factoring? G. Not C. G. C. F. GCF. Yes, GCF. I can take out a 3. Now be careful. I started with a trinomial. I got to end with a trinomial after you factor out that GCF. And in this case, the GCF is 3. 3 goes into everything. So if I take the 3 away from this, I'm left with S squared. If I take the 3 away from this, I'm left with 2S. Remember, you're dividing it out. You're dividing it out. And if I divide a 3 away from this, I'm left with 1. 1? Well, that's easy. There's only one way to multiply to 1. S and S. Isn't there only one way to multiply to 1? I mean, I know there's a million ways, a billion jajillion. But really, there's only one. 1 times 1. 1 times 1. And they have to add to give me 2. Well, wait, it's positive 2, so they're both positive. What do you think? Not too bad. This one's kind of tricky. Hate the orange color. Hate red too. Let's go to blue. All right. Oh, this is a fatter blue. All right. So W and W. They got to add, because it's a plus, to give me 15. So let's see. 6 and 6. No, those don't add to give me 15. Let's see. 4 and 9. Those don't add to give me 15. 3 and 12. Oh, those add to give me 15. So 3 and 12. And because it's positive and they got to add up to positive, everything's got to be positive. Nailed it. Oops, got a GCF. GCF alert, GCF alert. What can we take out of a 5, a 40, and an 80? You got it. It's a 5. Take a 5 out. You're left with n squared plus 8n plus 16. Now later on you're going to learn this thing's called a perfect square trinomial. Some other day. You'll see why in a minute. Maybe. N and N. Because of the plus, they got to add to 8. They got to multiply to 16, but they got to add to 8. So two numbers that multiply to 16 that add to 8. Oh, 4 and 4. And since it's positive, they both have to be positive because they got to add up to positive 8. And by the way, this is the reason this is called a perfect square trinomial, because I can rewrite this like this. 5n plus 4 squared. If I wanted to. By the way, at this point, now if you're getting a little handle of this, pause it, see how you do. Pause it, see how you do. Stop watching the performing monkey do some things. Try some things on your own. See what you can do. If you say, oh, I can do this one on my own, do it. W and W. This tells me the numbers have to add to give me 5. They have to add to give me 5. So there's two ways to multiply to 6. 1 and 6 and 2 and 3. Now, if you use the clues I give you that they have to add to give you 5, you'll pick the right pair. I know these subtract to give you 5, but that's not going to work. That's not going to work in this case. They have to add to give me 5. So I have to pick this pair, 2 and 3. Now, they have to add to give me 5, and they got to add up to negative 5. They got to add to give me 5, but it's got to be negative 5. So that means they both have to be negative. All right, I think this is the last one on this page. Nope, I got to take a break. Caught me again. Anytime this number is not a 1, look for a GCF. Look for a GCF. And in this case, yes, of course, it's got a GCF, 9. 9 goes into all of these. N squared plus 6n plus 9. Oops, another perfect square trinomial. You'll see why in a minute. N times n. They gotta multiply to 9, but add to give me 6. Now, two numbers that multiply to 9 that add to give me 6. Oh, 3 and 3. Now, wait a second. They got to add up to positive 6. Oh, plus 3 and plus 3. Remember, when this is a plus, they're going to add, and signs have to be the same. I don't care if they're both negative or they're both positive. They have to be the same. Oh, look, not a 1. Got to look for a GCF. So I can take out, obviously, a 2, and I'm left with d squared minus 81. Oh, isn't this dots, difference of two squares? Oh, yeah, that's that easy one. That's that easy one. That's that one where you go, okay, d times d is d squared. 9 times 9 is 81, but they got to have different signs because remember, this is a minus, and they have to subtract up to 0. There's like a 0 d's in there. That 0 d's is missing, but they got to add up to 0. That just means one's got to be plus, one's got to be minus. 24. Two sets of parentheses. C and C. Now, in this case, they have to subtract to get 5. I don't care about the sign right now. They have to subtract to get 5. Well, okay, so I can either use 1 and 6 or 3 and 2. Which pair subtracts to give me 5? Again, you got to use those clues. Subtracts to give me 5. Oh, that would be 1 and 6. If I subtract those, 6 minus 1 is 5. But, I want a negative 5. So the larger one has to be negative and the smaller one has to be positive. And again, negative 6 plus 1, that gives me negative 5. And that's what I want in the middle. All right, the number in front is not a 1. Look for a GCF, and I can take out a 4. And I'm left with t squared minus 16. Oh, that's that perfect square thing. Look at those. So I know how to do that one. Two sets of parentheses. T's at the beginnings. What gives me 16? 4 times 4. You just take the square root of it. And one's plus, one's minus. All right, here we go. That's so much fun to do. I'm going to do that like 100 times. G and G. Now, it's a minus, so they have to subtract. I keep saying that because I want you to think that. They have to subtract to give me the middle. So I need two numbers that multiply to 28 that subtract to give you the middle. And I always start with the two closest to each other, especially since this is a 3. Then they got to be kind of close to each other. And wouldn't you say 4 times 7, they're kind of close to each other. And when I subtract them, I get 3. So 4 and 7. But wait a second, I want negative 3. So the larger one has to be negative and the smaller one has to be positive. Now that's generally always going to be the case, but when you get the difficult factoring over there like 45, 46, it'll be a little bit more tricky. All right, number in front is not a 1. Brain cramp. So you have to look for a GCF. Now, I look at 72 and I say, okay, easiest way is 8 times 9. I wonder if 8 or 9 goes into 128. Well, do you all know the divisibility rule for 9? The divisibility rule for 9, or for 3 for that matter, is add up the digits, 1 plus 2 plus 8. 1 plus 2 is 3. So if I add these up, I get 11. if this number is divisible by 9, the whole number is divisible by 9. But it's not. So 9 does not divide evenly into 128. So I'm not even going to try it. But 8 does. And 8 turns out to be the GCF. This is kind of a tricky problem. So I take out an 8, and I'm left with 9g squared minus 16. Oh, wait a second. Isn't 9 a perfect square? And isn't 16 a perfect square? So I've got that different, but still difference of two squares thing going on. So I'm going to do two sets of parentheses. What multiplies to give me 9g? Now remember, when it's the difference of two squares, the parentheses have to be exactly the same. 1 plus 1 minus. So 3g, 4, and 4, 1's plus, 1's minus. Last one, and then I'll take a little tiny break. You won't even know it, but I'm going to anyway. This is a perfect square trinomial right away. They have to add to 144. Add to 144. Well, everybody knows 144 is that really cool number when you're like in 5th grade. What's 12 squared? Oh, it's 144. Ooh, I knew that. You know. Anyway, 12 times 12 is 144, and they have to add up to 24, and clearly 12 times 12 is 24, so 12 and 12. The signs have to be the same, and they both have to be positive. Okay, here we go. N and N. They have to add, well, wait a second. It's 2. There's only one way to multiply to 2. It has to be 1 and 2. And because it's positive, the signs both have to be the same, and they got to add up to -3. Oh, done. Number in front is not a 1, so you have to look for a GCF. And clearly 4 goes into all of these. X squared minus 6x plus 9. Oh, didn't we do this already? I think we did this one already. X and X. All right, so they got to multiply to 9, but they got to add to give me 6. Well, that's 3 and 3. But wait a second, it's -6. Both signs have to be negative. By the way, you should be pausing this now. We haven't done purple yet. H and H. They got to multiply to 12, but add to 7. Oh, 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. But since it's positive 7, they both have to be positive. I know I'm flying through these now because I'll go slower on some harder ones. Like this is a harder one. But remember, the first number is not a 1, so we're going to look for a GCF. Now, the only number that goes into 13 is 13. And lo and behold, 13 does, in fact, go into 52. By the way, if you're a card shark, 52 cards in a deck, 13 cards in a suit. So you should know that 13 goes into 52. But if you didn't, you should check it. Just take your calculator, divide 52 by 13. You're like, oh, it goes in there 4 times. So n squared minus 4n plus 4. If you divide this by 13 and this by 13 and this by 13, this is what you end up with, 13. N and n. Now they got to multiply to 4 and add up to 4. Add up to 4. Multiply to 4 and add up to 4. Oh, that's 2 and 2. Since this is negative, they both have to be negative. No GCF here, but it's a little bit harder. So start recognizing things. Anytime there's a minus sign here, it's a little bit trickier. It's actually always a little bit trickier. So I need two numbers that multiply to 36, but subtract to give me 16. Subtract to give me 16. Well, 16's a big number. So my number's got to be way far away from each other. Clearly, I wouldn't pick 6 and 6. 4 and 9 aren't far away from each other, but I subtract them, I only get 5. 3 and 12, those are kind of far away from each other, but those don't subtract to give me 16 either. And so it was kind of a tricky one. It's 2 and 18. Kind of a tricky one there. So I know it's 2 and 18. Now they have to subtract to give me positive 16. So that means the larger number has to be positive and the smaller number has to be negative. This is one that's kind of difficult if you just don't know, but I know that they have to multiply to positive 225 and add to give me 30. Add. I'm just going to help you with this one. It's 15 and 15. 15 times 15 is 225, and 15 plus 15 is 30. But they both have to be negative. Q and Q. Now start taking some hints from me. They got to multiply to this, but subtract to give me this ginormous number 18. 18's big. So if that's the case, if 18's big, I don't want numbers that are close to each other, 5 and 8. I want numbers that are really far away from each other. So I might start with 1 and 40. Nope, those don't subtract to give me 18. Then I would go, 2 goes in, 2 and 20. 2 times 20 is 40. And if I subtract them, they give me 18. So 2 and 20. Number in the middle is big. Numbers have to be far away from each other. Number in the middle is small. The numbers have to be close. So, let's see. Wait, they have to subtract to give me negative 20. That means the bigger one has to be negative and the smaller one has to be positive. Okay, kids, here we go. Number in front is not 1. So we need to see what number divides evenly into 15, 90, and 35. Well, I know 5 goes in, but maybe 15 divides in. And if you were to take your calculator out and say 90 divided by 15, you say, that's 6. You say, 135 divided by 15, that's, that's 9. Okay. So I can take out a 15 and I'm left with, look at this. We're going to see this again. A squared minus 6a plus 9. Haven't we factored this thing already twice? Wow, I didn't even realize that was in there twice. That's sort of annoying. A, it was with different letters, but A, multiply to positive 9, add to 6. 3 and 3. But it's negative 6, so they both have to be negative. So I've taught you some cues. I've taught you some clues, and this one looks really difficult. It's got that big number 110. But remember what I taught you. The number in the middle is 1. It's 1. And this is negative, so they got to subtract to give me 1. Well, if the numbers in the middle is 1, they got to be right next to each other. 7 and 8, 8 and 9, 9 and 10, 10 and 11, 12. What numbers multiply to each other that are right next to each other that will give me 110? 10 and 11. 10 times 11 is 110. And they're right next to each other, so they subtract to give me 1. Now, wait a second. They actually have to subtract to give me negative 1. So that means the larger one has to be negative and the smaller one has to be positive. Now, this one, notice the contrasting between, this one's actually, they're both the same sign. So anyway, this number, let's see. G and G. Multiply to 56. Add up to negative 15. Well, wait a second. They got to add to give me 15. Well, the easiest way I know to multiply to 56 is 7 and 8. 7 times 8 is 56, and those add to 15. Good. And they both have to be minus because the middle's minus. We're getting to the hard ones, but I'm going to do those in another video. There we go. All right, so I'm going to finish these 3 or whatever, and then I'm going to do the next video. V and V. They got to multiply to positive 121 and add up to 22. Well, the only way I know to multiply to 121 is 11 times 11. Oh, those add up to 22. That's nice. 11 times 11. But they both have to be positive. All right, so take a look at this one right here. Contrast this one with this one. This one had a 1 in the middle, so the numbers had to be right next to each other. This one has a 25 in the middle. That's ginormous. So the numbers aren't even going to be close to each other. They have to be far away from each other. That's where I said the first thing you have to recognize is that you're subtracting. You're going to subtract to give me 25. As soon as you're going to subtract, you're like, okay, should the numbers be close, small number, or far away, big numbers? In this case, since 25 is ginormous, I want my numbers way far away from each other. So I could pick 9 and 6, but they don't subtract to 25. I could pick, well, the only other thing I know goes in there is 2, besides 1 and 54. I mean, I could do 1 and 54, but when I subtract those, I get 53. That's not going to work. And 2 goes in. 2 goes in 27 times. And when I subtract those, don't I get 25? Sure enough. So 2 and 27, it has to be negative 25, larger negative, smaller positive. And now we start harder factoring. So what I'm going to do now is I'm going to stop now. I'm going to create another video. The reason I know this is harder factoring is because the number in front is not a 1 and there's no GCF. So it's not like in the past, I've been able to just take out the GCF and end up with a kind of an easy one. But this case, because this is 13, I can't take it out. So we'll do the harder factoring in the next video. And if you want that, there should be a link downstairs, down in the show notes, down there at the bottom of the video that you can click on so you can get to the harder factoring. All right? So that's it for that. Good luck, kids. Goodbye.